Okay, on to page 14. Page 14 begins with this souvenirs question. Emily wants to buy turquoise stones on her trip to New Mexico to give to at least 4 of her friends. The gift shop sells stones for either $4 or $6 per stone. Emily has no more than $30 to spend. Make a graph showing the numbers of each price of stone Emily can purchase. So notice that the X is your $4 stones and the Y is your $6 stones. Now we have 2 inequalities to graph here. We have a cost inequality, which says $4 for each X stone and $6 for each Y stone can be no more than $30. So there's your first inequality. The second inequality has to deal with this. She wants to buy for at least 4. So the number of stones she buys, X plus Y, has to be greater than or equal to 4. So, in both cases, it would be nice if these were in slope-intercept form. So let's convert them. This one, we're going to subtract X from each side, which will give us Y is greater than or equal to negative X plus 4. So we will graph that with blue. So negative X plus 4 means we start at 4 and we go down 1, right 1. That is a solid line. So we would draw a straight line through those points. Now we're not going to worry about shading yet, okay, but we do need to shade when we get there. The other equation, we're going to subtract 4x from each side. Notice I'm not writing it directly underneath the 30 because you can't subtract it from 30. That gives us 6y is negative or is less than or equal to negative 4x plus 30. And then we are going to divide by 6. Now, I know what you're thinking. 4 isn't divisible by 6. So what? Write it as a fraction. That would be negative 2/3 x plus 5. So we'd start off at 5 and go down 2, right 3. Down 2, right 3. And that would also be a solid line through those points. Okay? Now, notice the shading here. Okay? That's the second line, which is this line. And that was the first line up here, which I did them both in the same color. So that was, I guess, kind of a mistake, but not really a big deal. Notice that we're supposed to be shading above the first line. And we're supposed to be shading below the second line. So we're supposed to shade in between, and that would complete our inequality. It says list 3 possible solutions. So all we need to do is name literally any 3 points that are in or on those lines, because the lines themselves are part of the solution as well. So you'll notice I've drawn red dots at 3 points. Here are 3 solutions. 1, 4. 3, 2, 5, 1. That's only 3. There are a lot of exact points you could use. You could use 5, 0. You could use 6, 0, 7, 0, 4, 0, 3, 1, 4, 1, 6, 1, 4, 2, 2, 2, 1, 3, 2, 3, 3, 3. There's a lot of options. You just need to pick 3 of them. Okay, on to number 71. Write a system of inequalities to represent the sum of 2 positive integers, that'd be x plus y, is less than 80, and their difference, so x minus y, is more than 10. Simple. Simple. Doesn't even say solve it, just says write it. On to number 72. Okay, 72 through 76 are all exponent rule problems. So this requires us to remember back to what we did before we started chapter 4. You'll notice the first one has to the 0 power. Anything to the 0 is 1. So this equals 1, and we move on to the next problem. Okay, on the next problem, we're multiplying 2 monomials. When we multiply the same base, we add the exponents. So that would be a to the 3 plus 5 and b to the 5 plus 4, which would be a to the 8th, b to the 9th. Done. All right, number 74 deals straight power rule. Remember that the 3 has a first power on it. We're supposed to multiply 4 times each of the exponents. So 3 to the 1 times 4, g to the 4 times 4, h to the 3 times 4. That is 3 to the 4th, g to the 16th, h to the 12th. 3 to the 4th is 81, g to the 16th, h to the 12th. On number 75, we're dealing with the quotient rule. Basically, we have to deal with negative exponents because we're not allowed to leave negative exponents. So the first thing we do is we do the division. What is 42 divided by 2? That would be 22. Now, what I'm going to do is I'm going to move all of the other variables to the top. So that would be m to the negative 5th, m to the negative 1st, because this has a first power, and I move it up, n to the 6th, n to the 2nd, because when I move this n up, it becomes positive, and p to the 2nd as well. Now, there are some like bases here, so I should add those exponents. So m to the negative 5 plus negative 1, n to the 6 plus 2, and still p to the 2nd, which is 22, m to the negative 6th, n to the 8th, p to the 2nd. Now, we're very close here. The only problem is this negative exponent has to be pushed back down. So that would be 22, n to the 8th, p to the 2nd, over m to the 6th. All right, finally, number 76 puts a couple of these rules together. So we'll start by simplifying the top. That would be 2 to the 2nd, a to the 7 times 2, and b to the 1 times 2, because remember there's a 1 and a 1, over 48b to the 4th. So we're just going to leave that alone for now. That is 4a to the 14th b squared divided by 48b to the 4th. These two b's would move down and become negative and combine, and 4 over 48 would reduce to 1/12. So we would end up with a to the positive 14th over 12b to the 2nd. Again, that's an Algebra 1 skill. If you're having problems with it, you should be watching videos online on exponent rules, specifically the quotient rule, the product rule, and negative exponents. All right, a couple problems left. 77 and 78 deal with adding and subtracting polynomials. Remember that when we add polynomials, we basically can ignore these parentheses, and we're just combining like terms. So the only like terms we have there are 8a and 9a. So we're going to bring the negative 3a squared down because there are no other a squared terms. We're going to add 8a and 9a together, which would be 17a. And then we're going to bring the 3 down, so plus 3. That is as good as that's going to get. Now, when there's a negative sign in between, we have to actually distribute negative 1 through the second set of parentheses. So we can drop the first set, but the second set we have to distribute. Then we combine like terms. So we'd have negative 2a squared plus 13a plus 8. And then the final problem on page 14 is p plus 7 to the 2nd power. Remember what that says. That says p plus 7 times p plus 7. So we showed several different methods for this in class, and it doesn't matter which one you use as long as you get it correct. Basically, this is a FOIL problem. We need to make sure that everything in the first set of parentheses multiplies everything in the second set of parentheses. So that would be p squared plus 7p plus 7p plus 49. Then we combine like terms to get p squared plus 14p plus 49 for our answer. Now you could just as easily do the box method, so I'll show that as well. Remember that that's a binomial times a binomial. So we would make a 2 by 2 box. We'd put p plus 7 on each side of the box. And then in each box we would put the area. P times p is p squared, 7 times p is 7p, p times 7 is 7p, and 7 times 7 is 49. Those are like terms, so they get combined. You get the same exact answer. P squared plus 14p plus 49. So it doesn't matter which method you use as long as you find one that works for you. That does it for page 14.